Hi, this is Alex from devstories.eu. Light LLM, the Universal LLM Gateway, episode 16 of 24. You want to log all LLM traffic for debugging, but what happens when a microservice submits highly sensitive compliance data that absolutely cannot be saved? You might assume you have to disable observability globally, making your entire system blind just to protect a few specific API routes. Dynamic callback management resolves this tension by letting you control logging on a per-request basis. In a standard light LLM setup, callbacks handles sending your request and response payloads to external observability platforms. You configure platforms like Langfuse or Datadog at the proxy level, and by default, they capture everything passing through. The common misconception is that this logging is an all-or-nothing system. People often think that to handle sensitive data, they must deploy a completely separate proxy with logging turned off. Dynamic callback management removes that extra work. Consider a microservice handling medical records. The application needs to process patient symptoms through a language model, but sending that sensitive patient data to a third-party logging stack violates compliance. To prevent this leak, the microservice simply adds a specific HTTP header to its outgoing request. This header is called x-litellm-disable-callbacks. You set its value to a comma-separated list of the specific platforms you want to bypass. For the medical records service, the microservice passes the header with the value Langfuse, Datadog. When the light LLM proxy receives this request, it evaluates the header before triggering the language model. The prompt is sent to the provider and the response is routed back to the client as usual. The intervention happens during the telemetry phase. The proxy reads the disable header and actively blocks the payload from being forwarded to the specified observability endpoints for that single transaction. Meanwhile, all other applications hitting the same proxy concurrently continue logging their traffic without any interruption. This is where it gets interesting. Giving clients the power to disable their own audit logs introduces a potential security risk. In highly regulated environments, developers should not always have the authority to hide their traffic. If your infrastructure requires a strict, unalterable audit trail for every single prompt, you must enforce it centrally. You handle this using compliance locking. Inside the proxy configuration file, within the general settings block, you set a parameter named allow dynamic callback disabling to false. This single setting establishes a strict global policy that overrides any client-side instructions. If a microservice attempts to pass the disable callbacks header while this lock is active, the proxy does not silently ignore the header. Instead, it rejects the transaction entirely and returns an HTTP 403 forbidden error. This mechanism guarantees that traffic either complies with the mandatory global logging policy or it is dropped before reaching the language model. The true utility of dynamic callback management is that it shifts data privacy from a rigid infrastructure deployment into an agile request-level parameter while still giving platform engineers the final say on compliance. Thanks for listening. Happy coding, everyone.